Okay, today we will look at the problem 606, construct string from binary tree. So we are given a binary tree as we can see here. What is asked in the question is to do a pre-order traversal. I hope you know what is pre-order traversal. It is basically you print root, then left subtree, then right subtree in this order. So after so it's basically doing pre-order traversal and then return this string with parentheses. So what you have to do is to print a left root node, then open a parenthesis, print the left subtree, close it, and then print the right subtree. So this would go on recursively to do the same for its subtree. But the confusing part comes here that omit all the empty parentheses pair that do not affect one-to-one mapping relationship between the string and the original binary tree. So what it basically means is that if let's say a node is not a root node, in this case it is 2, then in the parentheses we have to include a the null left node also. It basically means that only. So only that null you have to include in a parenthesis, which is on the left, which is the left child, and also which is not a leaf node. So let's do a dry run to see how this works. So first we'll visit our root, we will print it. Then we will first go to the left side, then after that to the right side. Now going to the left side, we will check that 2 has now become root. So we will print 2, then we will go to its left child. We see that it is null. But what condition we have put? If the parent of the null is not a leaf node and it is the left child of the parent, then we have to include it in the parenthesis. So we will open a parenthesis and then close it. Now after visiting the left, now we will visit the right. We will open a parenthesis, include 4 and then close the parenthesis. So we have completed the left subtree of 1. Now let's go to the right. For right, we will again open the left parenthesis, go to 3 and then close it. So this is how we will get the output. Now let's quickly look at the code. By doing a pre-order traversal, so let's create a function for pre-order. We will pass here node root. We will check if root is not equal to null, then we can do the pre-order traversal. We will also start by taking here a string answer as the answer variable, which will store the required answer. So first we are trying to do the pre-order traversal. We will add the node here first. So note that here root val is in integer value. So first we have to convert it into string to add into string, and then simply do the left traversal. And the right traversal. Okay, but since we have to add parentheses here, we need to open left parenthesis just before the left traversal and close parenthesis right after the left traversal. Similarly, that we have to do again for right subtree also. So we will do answer dot pushback and answer dot pushback closing parenthesis. Similarly, same here for left, right also. So now this will enclose the left and right subtree within the parenthesis. But again, now we have to look at the condition which we have seen. So what was the condition? If it is not a leaf node. So when it is not a leaf node, when left, when root left is not equal to null or root right is not equal to null, then this is a this is not a leaf node, so we can add a opening parenthesis. And similarly, to add a closing parenthesis, this will the condition will be the same. So we are done for the left subtree. Now let's look at the right subtree. So in right, we do not need to add parenthesis for the null part. So we just need to check that if root right is not equal to null, that would just do the part. If that's the condition, we need not to add the opening or the closing parenthesis. Okay, now let's call the pre-order function and then return answer. So let's check if we have a clear answer. We will have done the pre-order traversal. We have added this. Let's check. Similar here also, we need to check. Okay, it got accepted for the test case. Let's look at the hidden test cases. And it is got accepted. Thanks for watching.